Okay, so we left off in our last video talking about these and how they were kind of like, we're seeing like patterns here and stuff, and like we're seeing that inner function and stuff. So what can happen is, don't forget about this, every time we have a constant we can pull it out, right? We can pull the constant out of the integral. It's not a big deal, we kind of remember that. This is going to be important for us in this property, so just don't forget about that, okay? So let's just look at this one again. It's pretty simple. We're still just recognizing the pattern. So let's just go through this like we would. So do you see a function and its derivative? And usually that function is inside of something. It doesn't have to be inside of something, but in this case I see a function which is 5x. I see its derivative, which is 5 dx. And this outer function is just the e to the power of something, right? So that's like kind of what's going on. So what we're going to do is, step one is going to be to pick u. Pick u. It doesn't have to be u, it's just what we use in this case. Oops, sorry. So u is going to equal 5x. And then step two, we're going to find du, derive it. Don't forget that we're taking the derivative of this, so that's du dx equals 5, right? But what I'm just going to write is du, the derivative of u is 5 dx. Okay? So do you see how the green and the blue up top are kind of already taken care of? They're already like, you know, included in these in this set of rules here. These are the rules, whoops. These are the rules we got to go by in this box. So I'll make that a box. Then we do our rewrite. So now we do our rewrite. Notice that there's another function here that's kind of weird. We did it with a square root or with a square, but this time we actually have the exponential function. And this is where some people get a little stressed, but we're going to rewrite, and we're going to show how it's not too bad. So we get the integral of, the e is obviously stuck there, so it's e to the u, right? To the u, just the green stuff. And then exactly that blue stuff precisely shows up, du. Now I know that it's broken in two places, but it's multiplication, so the order doesn't really matter too much. So can we all agree that this integral becomes this integral? And can we just do this integral as if it were a brand new problem, right? So we think about this for a second. We say, what's the integral of e to the x dx? Well, that's e to the x dx, right? Well, that's e to the x, sorry, plus c. So in other words, we have e to the something plus c is our final answer, but we need it to be to the u. And I believe, if I'm not mistaken, that u was 5x. So how do we know if we're right? Well, we check our answer by deriving our solution, because we anti-derived to get that, basically. So if we derive, we should get back to where we were. Makes sense? So we'll check it. If y was e to the 5x plus a constant, I could put a constant there if you want, like 21. I just randomly decided a constant. And now what's y prime? Well, it's e to the 5x. You rewrite it. You chain rule it by 5, and the 21's gone, so it's 5 e to the 5x. Is my derivative. Go back to the top, and that was exactly my integrand, 5e to the 5x. So we're doing pretty well now. I think with all that explanation, we can be able to pick up the pace a little bit. We're going to go to the next one. We're going to look at this one. It's not going to be perfect. We're going to have to do something different. Do you know what we're going to have to do differently? We're going to have to multiply and divide by a constant. You're not going to see that you're multiplying and dividing by a constant necessarily, but I'll show you. We'll see. So let's go to this and let's pick our u. So first we pick our u. So do you see something inside or a function that could be derived? So x squared's derivative is 2x. You know, the power of 2. When you derive that, you get the power of 1, right? So what I'm saying is that the u is going to be this part right here. So u is equal to x squared plus 1. Okay. Step 2 would be to derive that. So I'm not going to do du dx. I'm just going to do du equals 2x dx. All right. And so now we look at how are we doing in terms of, we don't need to number this every time, but I'm just going to try to show you. How are we doing in terms of rewriting this integral over here? So now we want to rewrite this integral, right? And I'm just going to write the integral, and it's something all squared, right? We know it's u squared. That's kind of easy to do. But we got to figure out what's going on with this. This is where we start to run into like a jam. This dx and this x doesn't really work. So here's what I would recommend. Some people just try to like plug back in and like add or divide a constant if they need it. That's fine. I've had a lot of people that works for them. But what I've always done is I've tried to get the dx alone. So I would always get the dx alone. So let me show you what I'm doing. I'm going to divide by 2, right? Or I guess I would just strip all the constants off of it. But if I do that, some people divide by 2x even, which is kind of weird, but we'll allow it, I guess. So if you do du over 2x, right? So now dx is du over 2x. So let's look at that for a second. Here we go. What do we got? Dx is du over 2x. So this right here is du over 2x, right? And then this x right here, we never really figured out what to do with it. It's still there, right? This x is still here. But they cancel out, and now you have everything in terms of u. So that's one way of doing it. My students kind of liked that. In some ways it's okay, but it's not really the method that most teachers would teach. So just so you're aware, so this is totally fine, this works. What most teachers would do here is they'd say du is 2x dx. They'd get the constants out of there anyways, right? So now what they'd do is they'd say, okay, well now we're taking a different route, so let's just do this. Now what they're doing is they're saying this integral it's the integral of something squared, right? So we know that that's good. We know the u is no problem. It's u squared. Now this du over 2 is equal to x dx. So what I like to say is, okay, here's x dx. That's equal to du over 2. And so I take the du over 2 and I take that 1/2 out. So that's the new way of doing it. And of course, even if you're up here, you have this du over 2, you take this 1/2 out. So this is, I'm going to call this option B, even though I did it first. Okay, you can kind of get away with using this, but it's not really the preferred way. And this is how most people would teach it, option A. So now what we can do is, so they just get their dx alone every time in option B. And in option A, we just get the constants out of there. So we're just looking at the like actual parent functions, because it's usually a constant that's going to mess us up. So I guess you can do either way, but I prefer option A. So let's antiderive this and pretend it's x. So now we have 1/2 u to the 3rd over 3 plus c. So we have, that's equal to u to the 3rd over 6 plus c. So this should be our antiderivative. So it's x squared plus 1 to the 3rd plus c. That's what it is in x's. And it should derive, so we don't use this, we use the x version. It should derive out back to what we had there. So that 3 and the 6, that 3 is going to come down, right? And then there's going to be a 2x here. And that's going to give us, that hopefully gives us what we need. So we have 3, then we have 2x plus 1, and then that's times 2x. And we're good to go. So hopefully that's good. Oh, I got a bad feeling about this though. I don't like where we're at. So let me see what's going on here. Something weird. Let's see what's going on here. Oh, the 1/2. That's right, the 1/2. Sorry, this has already been anti-derived, so I obviously, or this has been re-derived, so I confused myself pretty bad with that. It's this 3 that was scribbled out that comes down and cancels the 6 to get us like that divide by 2. And then the chain rule has the 2x in it. So you might want to ignore everything I've been saying for the last, I don't know, 20 seconds or so, because it was a lot confusing too. I was confused myself. So we are cruising right along. I've been doing it, they're about 10 minutes now, so Let's see if we can do another example. So let's try to go a little bit faster here. I'm going to pick the inside to be 2x minus 1. That's the u. That makes our du 2dx, right? 2dx. I don't like to have a constant there, so I divide. And so that's what dx is equal to. Okay, we see that u is 2x plus 1. So now when we rewrite our integral, we have the integral of, the outer function is the square root thing. Not a great square root in that case, but that's okay. The u is what goes inside of it. And what does dx actually equal? It actually equals du over 2. Check down here, don't miss it. So dx is du over 2, so that's why that's happening like that. Dx is equal to du over 2, so in a sense, I guess maybe what would be smarter would be to show dx equals du over 2. Therefore, du over 2 is what goes there. So now we have u to the 1/2, and we're trying to antiderive that, so it's going to be u to the 3/2 times 2/3 plus c. So connecting concept, because integration is more difficult, you should always check it by rederiving. So if we take this, right, for example, and we rederive this one, if you differentiate that, you should verify that you'll get the same thing. Did I get an extra 2 for no reason? That's the question. Oh yeah, I lost this 2 over here. So this is kind of annoying. See what's going on here? So this right here, this 2 right here, this goes out here, right? We talked about this before. So there's a 1/2 here. So there's a 1/2 here. There's a 1/2 here. So that cancels that. So that's all that. So now you have 1/3. That's why we have a 1/3. So these are canceled. And that's why they're showing 1/3. 2x minus 1/3 plus c. And this is exactly why you should always check your answer by differentiating. Okay, so if you differentiate this, you'll get 1/2 2x plus 1 to the 1/2. I think you'll multiply that by 2. That'll cancel. So you'll have the square root of 2x plus 1. And it's good. So that's sort of where we're at. I think we could probably stop there and keep this as a shorter video. So there we are.